Welcome to Callous Coder, and today we prove that computers have better taste than women.
Mirror, mirror. You are so hot that I can only say, goodness gracious, my balls are on fire.
Motherfucker! So for a proof of concept, I created an artificial intelligence that when it sees my face or that of a stranger, it will give compliments because I need that. I'm like a fragile Hollywood actor. I need constant affirmation and I'm so beautiful. But when it sees the face of my best friend, it won't be friendly.
Mirror, mirror on the wall, who's the fairest of them all? Oh my god, is there a troll convention in town? Fuck, man. Oh yeah, there is a troll convention in town. It's called Maurice. Mirror, mirror on the wall. You are so hot that I can only say, goodness gracious, my balls are on fire. Yeah. I know, right? I know, I got that same feeling when I look in the mirror.
Mirror, mirror on the wall, who is the fairest of them all?
Fuck me, you're so ugly, my eyes are hurting.
Now I have that same problem, Maurice, when I look at you. It causes an intense pain in my eye. Mirror, mirror on the wall, who's the fairest of them all?
Oh, my nipples are getting hard. You're the best thing I've ever seen.
I told you. I told you, ladies, and when a computer knows it, it is the fucking truth. So we've seen the demos. Let's jump into the code and explain a little what is going on. It is based on an LDA that is coded by somebody else. Link is in the description. I extended it with face detection because initially it only used an input image. And I extended it with voice recognition from Microsoft Azure. I use it in a different project that you will see soon on this channel. And it's inspired by Michael Reese, a great YouTube channel. I advise you to watch that. It is hard-coded because it's a proof of concept. In a proof of concept you want to prove the concept and move forward. So you don't care about clean code, you care about proving the concept. Here I parse the images. I have the training images in full size. I do the face detection on them, save them in that specific format that the model uses, and that's it. And here the model, this comes with the standard application. The model reads those images and trains the model. Here I actually do the facial recognition. I play a sound based on the label index. -1 is unknown, 0 is Maurice, 1 is me, and 2 is Mike Tyson. He's also in there. The max occurred, I take 3 measurements because the hair is a bit flaky. Sometimes in 3 measurements you get 2 different values. So I take 3 measurements and take the highest occurrence. I store a face every time that I do a mirror mirror. It will take a snapshot from the webcam and store it so I can use that for extending the training. And here I created a combine function, not the way to usually do it, but again, proof of concept. Detect and recognize a face. So first I do a facial detection in the image, and then I take that cropped image and put it into the facial recognition that you saw before. Getting the name from the indices is also hard-coded, and it's right here. It's only there for debugging. I write the name in the left corner in the first measurement to see how good the training was. Here I open the webcam that gives a continuous feed. Here is the hair cascade to do the frontal face detection. So when you're on your side, for example, it doesn't work, even though the face recognition algorithm is trained for all these weird angles. Here we register with the speech to text API with Microsoft. This comes in the example code. It's basically a matrix. Here we train the model and the hair is really quick. It's done in about, well, less than a second. The conformation of the images, and training it is less than a second. And this is the model that we can actually use to do the detection. Here I connect the speech recognition to see with a lambda, and that lambda will set a shared variable called text based on the detection. Or I could not understand if it was gibberish. To break off the session, that's also a lambda, because I do a continuous listening that allows for quicker interaction than doing one-shot voice recognition. And here we are in the main loop. I read from the camera. I check if that global text is filled with mirror mirror. And so I read another frame, and I do that 3 times, like I said, to get the highest occurrence. We use that for the prediction to make it a bit better. We take that highest occurrence, we play the sound like I said before, depending on the index, -1. And 1 are nice things, 0 are not such a nice things. And I show constantly the refresh rate from the image capture when there is no command to process. And if there is a command to process, we also show it until we do the voice the playback, then it freezes. I like that because then it has the idea that a snapshot was taken. And when you press Q, we just break everything off and release everything. It's that simple. So that is the code. I hoped you liked this episode with this little weird proof of concept for an even weirder product that I may or may not end up making, but I thought it was good and fun, so there you go. I hope to see you in the next one.